Hi, this is Nandini. Today, my presentation is regarding the diabetes regression analysis. In that, I'll explain about pattern of missingnesses of the data interactions and full model results. And in this presentation, based on the data, I analyzed a large medical data set to understand which body system variables helps predict the diabetes. And I used regression modeling and also explored how missing data behaves. Because in the healthcare industry, data missingness often carries a real meaning. So at the end, I built a full model that includes the main effects, pairwise interactions, triplets, and meaningful missingness indicators so that it gets a clear picture of the factors which is associated with the diabetes. First, uh, I started with loading the data. In this slide, I'll explain like I begin by loading the dataset, which containing the body system information for thousands of individuals. For the first step, we have to structure using the dim and head to ensure the data loaded correctly. Then I identify the target variable, which is diabetes status. It is labeled as DM, and I separated it from columns. Then we should not treat as a predictors. So as patient ID and the trained data set was labeled. And after loading the data, I also removed the rows where the diabetes outcome is missing because regression models requires the known outcomes. So after taking the known outcomes, finally I converted the diabetes variable into numerical format so that we can prepare it for analysis. Especially this step gets the raw data cleaned and ready for the modeling. Next step, we'll create the 10% of the sample. Why we are using the 10% sample here? Because the full data set is extremely large. So when it is large, running the data complex regression models, it will take several hours. Even it may fail at the end due to the memory limits or any other reasons. So to work efficiently, I pulled a 10% random sample of the data because this smaller subset helps us to test the code, explore the model behavior, and it helps us to identify the issues clearly. After clearing the issues, uh, once everything works smoothly on the sample, the same procedure can be repeated on the full dataset. It will strategically save the time while ensuring the analysis or accuracy of the data. Next step here I'll explain about the missingness indicators. Uh, it is one of the extremely main important part in the medical data sets because sometimes a value is missing not because it was forgotten but because the patient was not tested or did not report certain symptoms. That's why we can see the missing data. It may which may itself signal something meaningful. So if we see this slide, I created the missingness indicators for every predictor variable. Then I created a new variable that is 1 if the original value was missing and 0 if it was present. These indicators will let us know or allow us to check whether the absence of the information itself predicts the diabetes or not. And I also calculate how many total values are missing per row, and it helped me to identify the patterns such as patients who are missing a lot of information. And finally, I reordered the columns so the dataset becomes easier to read the analysis. And the next step, regression using missingness indicators. In this step, I run a regression model using only the missingness indicators as a predictors. This allowed me to test one important question, that is, does missing data itself help predict the diabetes? So, if this model has a meaningful predictive power, which is measured by the R square, it means that certain pattern of the missingness are not random for sample. If missing lab results or missing symptoms enters are associated with the diabetes diagnosis, then missingness becomes an informative signal. These allows us to identify the variables that might be missing not at the random, which is statistically important to account for. Next, identifying the NMR variables. After running the missingness model, uh, then I extracted the p values of each missingness indicators, because any indicator with p value below 0.05 is strategically significant, because these significant variables are likely not missing at random like NMR, meaning that pattern of missingness depends upon the diabetes outcome. For a certain instance, like patients with diabetes may not more likely to skip or fail certain tests. After identifying these variables, it helped me to improve our model later, and it will help us to improve the model, and later it ensures that we don't unintentionally remove meaningful information. Next, interactions among significant missingness indicators. Here, if multiple missingness indicators are significant, I test whether combinations of the missing values carry even more information, because this is done through an interaction model where two missingness indicators are multiplied together. So here the purpose is to see if jointly missing variables such as missing both blood pressure and cholesterol values, it will tell us more about diabetes than each alone. So I computed a new R squared value for the interaction model. If it increases, it means there are deeper meaningless patterns that improves our understanding of the data. Later, prepare predictors for full model. Before before building the final model, I just ensure that all predictors are usable or not. For that, first I checked whether any predictor is entirely missing, such as variables which cannot contribute to model, so they are removed. For the remaining body system variables, I use mean imputation. It helps to replace missing values with the average value of the variable. While not perfect, it is a standard method to prevent models from failing due to incomplete data. Especially, this step ensures we start the full model with a complete and consistent data. Next, building the full model. If you see in the slide, I created the full regression model. It includes all individuals' body system predictors, all pairwise two-way interactions, all three-way interactions like triplets, significant missingness indicators from earlier steps. This model helps us to capture both simple and complex relationship between the variables. For example, diabetes may not depend on single factor, but on combinations such as high BMI pulse, abnormal liver function, or certain respiratory and cardiovascular patterns. So I computed the R squared for this full model. It showed me the proportions of variations in diabetes status, and it explained by which is explained by all the predictors and interactions. At the end, after building the model, this model provided the most comprehensive view of the data. At the end, after building all the data and running the data, I saved all coefficients, standard errors, and p-values into a CSV file, and it which is used for reporting, further analysis, or visualization outside of the R. And it will this analysis reproductive, and it can be shared with others easily. If yeah, and thank you.